Hi friends, welcome back to Sea Level Physics. My name is Srinivas, known to be BS. In this video, we are going to discuss cross product or vector product. Okay. Before that, in previous lecture, we left with a small concept, that is examples for dot product. Let us see initially. Okay. Examples. Examples for dot product. What are the examples for dot product work done? Work done equal to F bar dot S bar, that equal to F bar dot R2 bar minus R1 bar. Here F bar means force vector, S bar means displacement vector. Again, displacement vector in the sense final position vector minus initial position vector. Right? Let us see. This is what on surface on which a block of mass M is resting. Okay, which is acted upon by some force vector F bar, like that. Right? What is angle made by force with horizontal, that is theta. So, on application of this force, body displaces from one position to another position. Okay. After some time, body reaches somewhere here. Now, this is what displacement vector from midpoint to midpoint. That is displacement vector. Now, what is the angle between force and displacement vector? Theta. Right? So, work done by that force vector is given by F bar dot S bar. So, the dot product of force and displacement vector mathematically equal to work done by that force. Right? If at all that particle or body, whatever it is, if it moves in three-dimensional space, then S bar can be written as final position vector minus initial position vector. See, as an example, is what XYZ coordinate axis, X, here it is Y, Z, right? Initially particle is somewhere here at A with position vector R1 bar with respect to origin, initial position vector R1 bar, right? An application of force, particle displaced from A to B, as an example. It displaced from A to B, right? This is what displacement vector from A to B. Now, when particle reaches position B, with respect to origin, this is what final position vector R2 bar, right? This is initial position vector. When particle lies at position A, R1 bar is the initial position vector. When it reaches B, R2 bar is the final position vector, okay, with respect to origin. Now, particle reaches, displaced from A to B, right? In that displacement, in that motion, particle has displaced from A to B, whose displacement is expressed by a symbol S bar. See, the head of R1 bar is joined with the tail of S bar. Okay. Now R1 bar and S bar are taken as the adjacent sides of triangle in the same order. Why? Because head of R1 bar is joined with the tail of S bar. So R1 bar plus S bar is mathematically equal to R2 bar, right? As per triangle of addition. These two are taken as the adjacent sides, taken in the same order. Then this is the closing side. R2 bar is the closing side of the triangle, taken in the reverse order. That is from the tail of R1 bar to head of S bar. This is what R2 bar. So therefore, R1 bar plus S bar equal to R2 bar. Now what is the displacement vector? S bar equal to R2 bar minus R1 bar. So S bar is replaced by R2 bar minus R1 bar. So if you are given initial and final position vectors, displacement can be written as R2 bar minus R1 bar. That is final position vector minus initial position vector. Let us see one example. Suppose F bar equal to a numerical, F bar equal to 2i plus 4j newtons, R1 bar equal to minus 2i plus 3j meters, R2 bar equal to minus I minus 4j plus 5k meters, as an example. right? Okay, if particle is acted upon by this much of force, which displaces from one position to another position, that is one point to another point, such that initial position vector is so and so, final position vector is so and so, then what is work done by that force on that part? Let us see. Find work done. Find work done by the force. Find work done by the force. See, what is the expression? Work done is given by a bar dot S bar. That is S bar equal to R2 bar minus R1 bar. So, before that we need to find S bar initially. Okay, S bar equal to R2 bar minus R1 bar. Now, what is R2 bar? Minus I minus 4j plus 5k. Minus, what is R1 bar? Minus 2i plus 3j. Minus 2i plus 3j. Right, that is here minus I minus 4j plus 5k minus a minus plus 2i minus a plus, that is minus 3j. Now on summation, see, minus I plus 2j, that is plus minus I plus 2i, that is plus I, minus 4j minus 3j, that is minus 7j plus 5k. This is the displacement vector S bar, right? Now what is F bar source? 2a plus 4j. This is S bar. Now take this expression, that is how to find W means, that is W equal to F bar dot S bar. F bar dot S bar. Now what is F bar? 2a plus 4j dot, what is S bar? I minus 7j plus 5k, right? I minus 7j plus 5k. Now how to find dot product of two vectors? See, sum of product of similar components, that is I dot I plus j dot j plus k dot k, like that. So here x component 2, x component 1 into I cap. So ax bx plus ay by plus az bz, that is ax bx plus ay by plus az bz. Okay, that is ax means 2, here bx means 1 into I cap, so that is 1. So 2 into 1 plus ay. What is ay? Y component 4 into, what is by here? Minus 7 plus, what is az here? There is no z component in F bar, so z component, that is az is 0 into, here what is bz? 5, that is 2 into 1 2 plus or minus 4 7 28 plus 0. So what is work done? 2 minus 28, that is minus 26 joules. So what is the SI unit for work done? Joule. Why? Because force and displacements, that is position vectors, are in a SI form. So work done must be expressed in SI, that is joule, minus 26 joule. Okay. So this is what work done, that is dot product of force and displacement vectors. Few more examples are there for work done. Let us see. What are the second example? Work done F bar dot S bar, that is F bar dot R2 bar minus R1 bar. Now remaining examples for dot product. What are the? Potential energy. Before that, in the same example, what is the instantaneous power for this force? Means instantaneous power equal to F bar dot V bar. The dot product of force vector and velocity vector is numerically equal to instantaneous power delivered by external agent, that is force. Okay. Now number 3, potential energy of electric dipole, UE equal to minus P bar dot E bar. U means energy, that is potential energy. Suffix E means electrical. In electrostatics, we have one relation. Okay, that is potential energy of electric dipole is given by minus p bar dot e bar, where p bar is nothing but electric dipole moment, e bar is electric field. Similarly, number 4, that is magnetic potential energy of magnetic dipole, that is ub equal to minus m bar dot b bar. Okay, ub means potential energy of magnetic dipole, which is given by minus of m bar dot b bar, where m bar is nothing but magnetic dipole moment, b bar is nothing but magnetic field. So these are related to secondary topics, will be known in further chapters. For the timing, accept the relations, that's all. Okay, so instantaneous power, potential energy of electric dipole, potential energy of magnetic dipole, work done, etc. Okay, there are few more examples also there. Okay, so this is about examples for dot product. Okay, similarly we have so many examples for dot product. Okay, now coming to today's lecture, that is cross product or vector product. Cross product or vector product. Okay. So far we have discussed dot product or scalar product, in which when two vectors are multiplied, the result is scalar. Here onwards, if two vectors are multiplied, we will have the resultant is again a vector. That kind of multiplication is said to be vector product or cross product. Okay, cross product, cross or vector product. Cross product or vector product. Right? Cross product or vector product. Let us see. Suppose this is what a plane. This is what a plane containing two vectors. What are the vectors? Let us see. This is A bar. Now this is B bar. So A bar, B bar are two vectors. What is the angle between these two? Let it be theta. Okay. This is what a plane containing two vectors, A bar and B bar, with theta is the angle between them. Theta is the angle between them. Alright. Now, the cross product of these two vectors given by A bar cross B bar, that is A bar cross B bar. A bar cross, see the operation here, cross. In dot product A bar dot B bar, one dot or decimal is placed somewhere here in between two vectors, but here it is cross between these two vectors. See the symbol, here it is dot, here it is cross. Both are different, not same. Okay, the cross product of these two vectors, that is A, can be written as A bar cross B bar. Okay, is given by AB sin theta, AB sin theta into some unit vector, say it is C cap, some C cap. The cross product of these two vectors is again a vector, is given by A bar cross B bar, which is equal to AB sin theta into some C cap, where C cap is the unit vector which is perpendicular to plane of given parent vector. See, this is the plane of given parent vectors. Now what is the direction of C cap? Perpendicular to this plane. Okay. Moreover, perpendicular to A bar and B bar also. Okay. Now we can have two options to get the direction of C cap, either upwards or downwards with respect to this plane. Both are normal only, but properly we can take proper direction of C cap by using two rules. Let us see later. Okay. C cap in the sense it may be upward or downward, but as far as rule is concerned, you must follow two rules, any one of those two rules. Okay, let us see later. For the time I am writing C cap. What is the direction of C cap? In case of A bar cross B bar, definitely the direction of C cap is normal to A bar, B bar, also normal to plane one. Now I am taking the direction of C cap is along this way. What is the direction of C cap? See, this is the direction of C. Right? This is the direction of C cap. See, the direction of C cap is normal to plane of A bar and B bar, and also normal to A bar and B bar also. Right? See, once again, C cap is normal to both A bar and B bar, and also normal to plane of A bar and B bar. Okay. Of course, if C cap is taken vertically downwards also, in that case also C cap perpendicular to A bar, B bar, and also plane. Right? But as far as rule is concerned, we have to consider vertical up only in this case. Okay, while calculating A bar plus B bar. Why it is to be taken like that? Let us see later. Right? For the time being accept. So this is what C cap. Now see what I am saying. The cross product of two vectors, again a vector. See, A bar cross B bar means the cross product of A bar and B bar, which is again a vector. Vector in the sense the product of magnitude multiplied by unit vector. See, AB sin theta is nothing but magnitude. C cap is direction. C cap is direction. This is what magnitude. This is what direction. This is what vector. A bar cross B bar, again a vector. It's not scalar. Vector. So vector equal to magnitude multiplied by direction. What is that vector? A bar cross B bar is again a new vector. Say it is C bar. I am writing C bar. So C bar equal to A bar cross B bar means say C bar, which is equal to AB sin theta means magnitude, that is mod C bar into C cap. See, as you know, A bar equal to mod A bar into A cap, B bar equal to mod B bar into B cap. Similarly, C bar equal to mod C bar into C cap. Right? That only written here. So A bar cross B bar equal to AB sin theta into C cap. Say C cap is one unit vector which is normal to A bar, B bar, and plane of A bar and B bar. Right? So A bar cross B bar equal to C bar, that is mod C bar into C cap. Vector equal to magnitude multiplied by unit vector. Right? Okay. Now mod A bar cross B bar, I am taking modulus. See, mod C bar, otherwise mod C bar equal, from this relation mod C bar equal to C bar by C cap. Mod C bar equal to C bar by C cap. That is mod C bar means AB sin theta here. AB sin theta. Right? AB sin theta. C bar means A bar cross B bar by C cap. Otherwise, I am taking modulus on both sides. Mod A bar cross B bar equal to mod of AB sin theta into C cap. I am taking modulus on both sides. So mod A bar cross B bar equal to mod A bar means A, mod A means again A, mod B means again B, mod sin theta means again sin theta, that is sin theta into mod C cap means, what is the modulus of C cap? C cap is unit vector. So modulus of C cap means 1. So AB sin theta into 1. Mod C cap. Mod A means A, mod B means B, mod sin theta means sin theta. That is mod C cap means, I am writing mod C cap. Mod C cap again 1. So mod C cap is 1. So ultimately we can write it as mod of A bar cross B bar equal to AB sin theta into mod c cap means 1. That is AB sin theta. Since mod c cap is 1. Why? Because c cap is unit vector, modulus of c cap is 1. So, the modulus of cross product of A bar and B bar is equal to the product of magnitude of either of the vector and sine of angle between them. That is the magnitude of cross product of given two vectors. Okay, given two vectors. So far we have magnitude of cross product of given two vectors one, right? Cross product of two vectors, again a vector no, means it should have direction also apart from magnitude. So far we have completed how to get magnitude. Now how to get direction of that new vector. What is the direction of A bar cross B bar? Let us see, right? Let us see, right? Suppose to get the direction of A bar cross B bar, we have two rules. What are they? Right hand screw rule, otherwise right hand thumb rule. We have two rules. Right hand screw rule. Right hand screw. See, this is what one right hand screw. This is the tip of the screw. This is the head of the screw. Take a look here. This is what? As an example, right hand screw. This is the tip of the screw. This is the head of the screw. Okay. Now see, both parent vectors A bar and B bar are joined coinitially somewhere here in its plane, in the plane, in this given plane. Okay. So this is the common intersection of two vectors. Right. Now take this right hand screw such that its length is perpendicular to given plane of vectors like that. And moreover, the head of the screw is to be coincided with common point of given parent vectors like that. Okay. Now, A bar cross B bar in the sense, A bar cross B bar in the sense, rotate head of screw such that from first vector to second vector. In A cross B, A bar cross B bar, A bar is the first vector, B bar is the second vector. Okay. A bar is the first vector. In case of A bar cross B bar, A bar is the first vector, B bar is the second vector. So A bar cross B bar in the sense, if you want to get the direction of A bar cross B bar, as far as right hand screw rule is concerned, take one right hand screw, okay, such that its head coincide with the common point of A bar and B bar, such that as shown in diagram, right? Now simply rotate the head of right hand screw from first vector to second vector. First vector A bar, second vector B bar. That is from A bar to B bar means, what is the sense of rotation here? From A bar to B bar in the sense, that is anti-clockwise sense. From A to B means in its plane. See, in this plane, from A to B means anti-clockwise sense. Now rotate the head of this right hand screw in anti-clockwise sense. See, like that. Now see the direction of advancement of tip of the screw. Direction of advancement of tip of the screw. See, is it upward or downward? It is upward. See, while rotating the head of screw from A bar to B bar, that is in anti-clockwise sense, like that. See, the tip of right hand screw going upwards. Okay. Now the direction in which right hand screw is advancing, that itself the direction of new vector. That is what the direction of resultant vector. That is A bar cross B bar is along positive axis in this example. So I am writing somewhere here. This is what? A bar cross B bar. A bar cross B bar. In fact, what is that A bar cross B bar? New vector C bar. New vector C bar. Right? Once again, see. Take a look. This is what? Right hand screw. How to get the direction of A bar cross B bar in the sense? Making use of right hand screw rule. One can assign the direction of cross product of given two vectors. See, this is the plane of A bar and B bar. Now, take this right hand screw such that its head joined with common tail of both vectors. Now, rotate the head of the screw from A bar to B bar. That is from A to B means anti-clockwise sense in its plane. Now, if it is rotated in anti-clockwise sense, the tip of the means the knife edge of the screw going upwards like that, going upwards. Now the direction which tip of the screw advances, that itself the direction of resultant vector, right? So what is the direction of resultant vector? This is the direction of resultant vector A bar cross B bar. Usually that is to be symbolized with C bar here, right? If you want to get B bar cross A bar, this is what A bar cross B bar. If you want to get B bar cross A bar, see once again. This is the given plane. This is what given plane. Alright. I am writing given vectors. This is what A bar. This is what B bar. B bar. Theta is the angle between them. Alright. Now how to get cross product of B bar cross A bar? This is what A bar cross B bar. If you want to get B bar cross A bar, B bar cross A bar means from B bar to A bar means what is the assign the sense of rotation. B bar cross A bar means clockwise or anti-clockwise. From B to A means clockwise in the plane of vectors. From B to A means clockwise. We should have clockwise sense. Now see. If you want to get B bar cross A bar, once again here B bar cross A bar. Now I am placing the head of screw somewhere here such that coinciding with common tail of B bar and A bar. Now I want to get B bar cross A bar, not A bar cross B bar. B bar cross A bar means B bar is the first vector, A bar is the second vector. Now in which direction head of screw to be rotated here to get B bar cross A bar? From B bar to A bar means clockwise or anti-clockwise in the plane of vectors. From B to A means clockwise. See, this is what head of screw coincided somewhere here. Now I want to get B bar cross A bar. From B to A means take the rotation of head of screw from B to A, that is clockwise. Clockwise means like that, rotate like that in the plane of vectors. Now head is rotated like that, clockwise. Now assign the direction of advancement of screw here. Upwards or downwards? Say properly, downwards. Tip going downwards like tip going downwards. So therefore, what is the direction of B bar cross A bar? B bar cross A bar in the sense that is vertically downwards. B bar cross A bar. As A bar cross B bar is C bar, definitely B bar cross A bar is minus C bar. Minus C bar. Why? Because in fact these two have same magnitudes. Why? Because given parent vectors are same, angle also same here. Therefore, A bar cross B bar and B bar cross A bar both should have same magnitude. But as far as direction is concerned, A bar cross B bar is upward, but B bar cross A bar is downward. Right? Now, as the direction of C cap is vertically upwards here, the direction of minus C cap is vertically downwards here. Vertically downwards. So this is what minus C cap. In fact, see, this is what C cap. Now this is what minus C cap. These two anti-parallel unit vectors. Okay, these two anti-parallel vectors. Okay, vector in the sense should have both magnitude as well as direction. If magnitude changes or direction changes or both changes, definitely that vector is said to be altered. So therefore, A bar cross B bar and B bar cross A bar both are having same magnitude. Direction, as far as direction is concerned, both are opposite to each other. Therefore, A bar cross B bar is not equal to B bar cross A bar. Alright? Okay. If B bar cross A bar is reversed end to end, then definitely that vector and this vector both one and the same. Provided if this is reversed end to end. If it is reversed end to end, then both one and the same. Okay. Why? Because direction only makes the difference between these two. Right? Okay. Now A bar cross B bar equal AB sin theta. So this is what in assigning this is what one rule in assigning the direction of cross product. What is that rule? So far we have discussed right hand screw rule. Right hand screw rule. Okay. How to assign the direction of cross product of two vectors making use of right hand screw rule means how to assign. Take one right hand screw. Take one right hand screw. Okay. Such that the head of right hand screw is to be coincided with common tail of both parent vectors. Now take the rotation of head from first vector to second vector such that its length is normal to plane of vectors. Okay. Now assign the direction of advancement of tip of the right hand screw. Okay. The direction of advancement of tip of right hand screw itself, the direction of new vector, that is cross product of given two vectors, right? Here it is A bar cross B bar in the sense. Here it is, see once again A bar cross B bar in the sense. If I rotate the head of screw, here tip going upwards. Tip going upwards. So that is the direction of A bar cross B bar. Find to get B bar cross A bar. See once again B bar cross A bar means from B to A means this time the head has to be rotated in the clockwise sense like that. If it is rotated clockwise, see the direction of advancement of tip of the screw going downward like that. So that is the direction of B bar cross A bar. Okay. Now coming to right hand thumb rule. One more rule we have in assigning the direction of cross product, that is right hand thumb rule. See, this is what right hand palm. Stretch your right hand palm such that thumb is perpendicular to remaining four fingers as shown. Okay. Now this is what top edge of the palm, this is what bottom edge of the palm. Okay. If rotation is in anti-clockwise sense, now simply just make it simply this bottom edge of palm is to be touched with the common point of the both vectors. See somewhere here. Suppose this is what A bar cross B bar. Now stretch your right palm such that thumb is perpendicular to remaining four fingers. Now here A bar cross B bar in the sense anti-clockwise. Rotation is to be taken in anti-clockwise sense. From A bar to B bar means anti-clockwise sense. In case of anti-clockwise sense, the lower edge of the right palm, after stretching your right palm as shown in somewhere here. Now the bottom edge of the right palm is to be placed on the plane of vectors. Okay, as shown. Now take the curling of four fingers from A bar to B bar. Take the curling of four fingers from A bar to B bar. That is in anti-clockwise sense. See, in fact, this is the plane of A bar and B bar. In fact, now from A bar to B bar means take your right palm such that the direction of thumb is perpendicular to remaining four fingers. Now, if you want to get anti-clockwise rotation, now bottom edge of the palm is to be placed on the plane of both vectors. Now, to get A bar cross B bar in the sense, now take the curling of four fingers from A bar to B bar like that. Take the curling from A bar to B bar like that after placing on the plane. Okay, from A bar to B bar. Now assign the direction of thumb vertical upwards. So that is the reason why this is what direction of A bar cross B bar. Direction of A bar cross B bar. Okay, direction of A bar cross B bar. Now here say, if you want to get B bar cross A bar as the diagram is concerned, B bar cross A bar in the sense, is it clockwise sense or anti-clockwise sense? See, from B bar to A bar means clockwise sense. From B to A means we have to take rotation from B bar to A bar, that is clockwise sense. Okay, if you want to get clockwise sense, now take your right palm such that as shown here, that is thumb is perpendicular to remaining four fingers. Now, if you want to get clockwise sense, the top edge of the palm is to be coincided with the plane of vectors like that. Top edge is to be coincided like that. Now take the rotation of four fingers from B bar to A bar, that is from first vector to second vector like that. Okay, now see the direction of thumb vertically downwards. Once again, from B bar to A bar means we have to make join the top edge of the right palm with the plane of the vectors like that. Now from B bar to A bar means from B bar to A bar, take the rotation from B bar to A bar like that. That is clockwise sense, B bar to A bar. Now see the direction of thumb vertically downwards, vertically downwards. So the direction of thumb here gives the direction of resultant vector, that is cross product of two vectors. Okay. Once again, see what is the reference, how to get direction of cross product of two vectors as far as right hand thumb rule is concerned means stretch our right palm such that thumb is perpendicular to remaining four fingers. Okay. If rotation is anti-clockwise sense, now simply touch this bottom edge of the right palm with the plane of vectors. Okay. That is from first vector. Now take the curling of remaining four fingers from first vector to second vector. Now see the direction of thumb, that is vertically upwards. That itself, the thumb itself representing the direction of resultant vector. If rotation is from second vector to first vector, that is from B bar to A bar here. Now simply make it reverse your palm such that top edge is coinciding with the plane of vectors. Now take the curling from B bar to A bar, that is clockwise sense. Now see the direction of thumb vertically downwards. So here thumb vertically downwards, that is resultant vector. Here thumb vertically upwards, that is resultant vector here. Okay, here vertical upwards, here vertically downwards. Okay, right. Now mod A bar cross B bar equal AB sin theta. Since mod C cap is 1. Okay, mod C cap is 1. This is what the magnitude of A bar cross product of A bar and B bar. Mod A bar cross B bar equal AB sin theta. That is mod A bar mod B bar sin theta. Also can be written as mod A bar, mod A means mod A bar, B means mod B bar, sin theta as usual. Sin theta as usual. Okay. This is number 1. This is number 2. Right. Now say C bar equal to mod C bar into C cap. Now C cap equal to C bar by mod C bar. C cap equal to C bar by mod C bar. C cap equal to C bar by mod C bar. Okay. C cap, that equal to C cap equal to C bar means what? C bar means A bar cross B bar. So A bar cross B bar by mod C bar in the sense mod of A bar cross B bar. Why? Because C bar is new vector, okay, which is result of A bar cross B bar. That is C bar in the sense A bar cross B bar. Mod C bar means mod A bar cross B bar. Mod of A bar cross B bar. Now what is C cap? It is unit vector which is perpendicular to A bar, B bar and plane of A bar and B bar. So this is what important relation. Unit vector perpendicular to A bar, B bar and plane of A bar and B bar. So unit vector perpendicular to A bar, B bar and plane of A bar and B bar. See here, C cap is perpendicular to A bar, perpendicular to B bar, perpendicular to plane of A bar and B bar. Suppose you are given two vectors A bar and B bar and are asked to determine unit vector perpendicular to both A bar and B bar, then you can find C cap as follows. That is A bar cross B bar by modulus of A bar cross B bar. Okay, right? Now One more point. If C bar is result of A bar cross B bar, as an example. If C bar is a new vector resulting from A bar cross B bar, that is cross product of A bar and B bar gives a new vector C bar, then definitely C bar means A bar cross B bar perpendicular to A bar, perpendicular to B bar, perpendicular to plane of A bar and B bar. So C bar perpendicular to A bar implies if C bar is A bar cross B bar, C bar must be perpendicular to A bar, must be perpendicular to B bar, must be perpendicular to plane of A bar and B bar. Okay, that is the rule of cross product. So the cross product of two vectors is always a vector, new vector, whose direction is always perpendicular to both parent vectors and also perpendicular to plane of parent vectors. Okay, plane of parent vectors. See here, C bar, that is new vector A bar cross B bar perpendicular to A bar, B bar and plane of A bar and B bar. Here B bar cross A bar is a new vector which is perpendicular to A bar, B bar and plane of A bar and B bar. Okay, correct? Now let us see the magnitude, the variation of magnitude of cross product of these two vectors with variation of theta. Suppose you are given a pair of vectors with theta is the angle between them. If you change angle between given pair of vectors, you can have different magnitudes of their cross product. Let us see if theta equal to 0 or 180, that is A bar and B bar are parallel to each other or anti-parallel to each other, means A bar parallel to B bar, otherwise A bar anti-parallel to B bar. Now 2 implies or 1 implies, whatever it is. 1 implies, what is 1? See, this is what 1. A bar, B bar are parallel to each other, otherwise anti-parallel to each other. If they are parallel, theta is 0. If they are anti-parallel, theta is 180. In both cases, sin theta vanishes. Why? Because sin 0, 0, sin 180 also 0. Right? As far as 1 is concerned, in vector form, A bar cross B bar equal to AB sin 0. I am taking 0 initially. A bar cross B bar equal AB sin 0 into C cap. Otherwise, AB sin 180. In second case, sin 180 into C cap. Sin 0, 0. So 0 into something, that is 0. 0. But it is it vector form or scalar form? It's not at all magnitude. It is cross product of two vectors. It's not magnitude. So definitely this is what magnitude. How to get vector? Magnitude multiplied by unit vector. That is 0 into C cap. 0 into some C cap. That is 0 bar. 0 bar. Magnitude is 0. But in vector form, 0 bar. 0 bar. Null vector. So cross product of two parallel vectors, that is a null vector whose magnitude is 0. Right? Coming to 180 degrees, AB sin 180 into C cap, for example. Sin 180 also 0. So 0 into something 0. But in vector notation, it is not 0, 0 bar. 0 bar. If it is magnitude, for example, mod A bar cross B bar, that is mod 0 bar. That is 0. This time 0. Not 0 bar, this time 0. Why? Because this is scalar form, means magnitude. It is vector form. Definitely should express in vector form, that is 0 bar, not 0. Here it is mod A bar cross B bar, that is 0. Right? So what is the reference? If given vectors are parallel or anti-parallel, means collinear. Okay, if vectors are parallel or anti-parallel, they are said to be collinear vectors. So, in case of collinear vectors, cross product always vanishes. Means the cross product of any two collinear vectors is a null vector. Is a null vector. Okay, whose magnitude is 0. Right? 0. So, cross product of two vectors can be 0. What is the reference? Cross product of two non-zero vectors can be 0, provided theta is 0 or 180 degrees. Now coming to 90 degrees. Coming to 90 degrees means A bar perpendicular to B bar. A bar perpendicular to B bar. In this case, 1 implies A bar cross B bar equal to AB sin theta. Theta means 90. AB sin 90. AB sin 90 into some unit vector. Okay. It is vector form, means magnitude multiplied by C cap. Here C cap must. Okay. Otherwise it is ruled out. Otherwise it is not at all acceptable. That is A bar. If it is modulus, no need to write C cap. Why? Because mod C cap is 1. AB sin theta 1 in that case. Okay. Mod A bar cross B bar equal to AB sin 90 into C cap. Some C cap. What is AB sin 90? Sin 90 means 1. AB into C cap. AB into some C cap. If I take modulus, that is mod A bar cross B bar in this case, orthogonal vector, that is mod AB into C cap. That is mod A means A, mod B means B, mod C cap. What is mod C cap 1? That is AB. Since mod C cap equal to 1. Why? Because C cap is unit vector. Okay, which is normal to given parent vectors. That is AB into 1. That is AB. Now, if given two vectors are perpendicular to each other, if given two non-zero vectors are perpendicular to each other, the magnitude of their cross product is equal to the product of their magnitudes. That is AB. On clubbing previous result and present result. In previous result, what is the modulus of A bar cross B bar? 0. Okay, this time AB. On clubbing both, we will have 0 less than or equal to mod A bar cross B bar less than or equal to AB. This is the range of magnitude of cross product of two non-zero vectors. Mod A bar cross B bar can be 0 or greater than 0, can be equal to A into B, or can be less than AB. Right? This is the range of magnitude of two cross product of two non-zero vectors. Okay, 0 less than or equal to mod A bar cross B bar less than or equal to AB. Right? AB. Okay, now coming to properties. What are the properties of, means characteristics of cross product of given vectors? Say, first property, A bar cross B bar is not equal to B bar cross A bar. Why? Because A bar cross B bar is here upwards, here downwards. So, cross product does not obey commutative law. So, doesn't obey, does not obey or do not obey commutative law. That is A bar cross B bar not equal to B bar cross A bar. Of course, both are having same magnitude, but direction is opposite to each other. A bar cross B bar is upwards, here B bar cross A bar is downwards. Simply, if it is reversed end to end, as an example, if it is reversed end to end, then both one and the same. If it is reversed end to end, means we have to multiply with negative side. It is reversed, it means negative sign. If I take negative sign somewhere here, then both one and the same. That is, but A bar cross B bar equal to minus of B bar cross A bar. Minus of B bar cross A bar means anti-commutative. That is anti-commutative. Anti-commutative. Directly it is not commutative but anti-commutative. Okay. A bar cross B bar equal to minus of B bar cross A bar. Important result. Alright. Now as far as the distributive law is concerned, cross product of given vectors obey distributive law. Distributive law. Obey distributive law. Obey distributive law. Suppose A bar and B bar are A bar, B bar, C bar are three vectors. A bar cross B bar plus C bar equal to first one. This is what first one. A cross B plus C. That is can be written as A cross B plus A cross C. So A bar cross B bar plus C bar can be written as A bar cross B bar plus A bar cross C bar. Right. Second notation, that is, if A bar, B bar, C bar and D bar are four non-zero vectors, for example, A plus B cross C plus D can be written as, see, A bar, B bar, C bar and D bar are four non-zero vectors. A bar, B bar, C bar, D bar. So A plus B cross C plus D can be written as A cross C, A bar cross C bar plus A cross D, A cross D. Okay. Similarly, here plus B cross C, B cross C plus B cross D, B cross D. Okay. See, A bar plus B bar cross C bar plus D bar can be written as A bar cross C bar plus A bar cross T bar plus B bar cross C bar plus B bar cross D bar. Okay. Both are distributive laws only. Okay. This is first law, this is second. This is valid for three vectors. This is valid for four non-zero vectors, right? Now, what about commutative law? Cross product do not obey commutative law. Do not obey commutative law. Sorry, do not obey associative law. Associative. Cross product of three vectors do not obey associative. Associative law in the sense A cross B cross C not equal to A cross B cross C. A cross B cross C not equal to A cross B cross C. Okay, right? So these are characteristics of cross product of vectors. Right? Now, what about cross product of given vector with itself? Next point, cross product of any vector with itself. That is something like A bar cross A bar, otherwise B bar cross B bar. See, A bar cross A bar. Cross product of vector A bar with itself. See here A bar cross B bar equal to AB sin theta into C cap. Okay. AB sin theta into C cap. Here A bar means A bar only. B bar means again A bar only. Again A bar only. Let us see one implies substitute in expression number 1, that is A bar cross B bar means A bar cross A bar. So A bar cross A bar equal to A means here also A into B. B means again A, that is A into again A into sin theta. Sin theta. What is angle between A bar and A bar? Parallel to each other. A bar parallel to itself. That is theta is 0. Sin 0 degrees. Into some unit vector perpendicular to both A bar and A bar. Say this is C cap. What is sin 0? 0. 0 into something. That is 0 bar. Equal to 0 bar. 0 bar. So, what is the reference? The cross product of any vector with itself is null vector or 0 vector. If I take modulus, mod A bar cross A bar, that is mod 0 bar, that is 0. Okay? Right. Similarly, we can have I cross I, J cross J, K cross K. Okay? As far as orthogonal unit vectors are concerned. Let us see orthogonal unit vectors. Orthogonal unit vectors. Okay? In case of orthogonal unit vectors, now see x-axis, y-axis, z-axis. Along x, I cap is the unit vector. Along y, j cap is the unit vector. Along z, k cap is the unit vector. Okay, I cap, j cap, k cap are the unit vectors in respective directions. Right? Now, I want to get I cross I. First result, I cross I, number 1, I cross I. What is I cross I? 1 implies, see, 1 implies I cross I. I cross I means instead of A bar, here I cross I cap is there, instead of B bar also I cap is there. So 1 implies A bar cross B bar equal AB sin theta into C cap. A bar cross compare, take it as A bar cross B bar. That is A bar cross B bar equal A, B sin theta. So I cross I equal to A means mod A bar. So here mod I cap. B means mod B bar. That is mod I cap again into sin theta. Sin theta means what is angle between I and I? I bar parallel to itself, that is theta is 0, sin 0 into here C cap. What is unit vector normal to I cap here? Normal to I cap here, J cap is there, K cap also there. We can take any one of those. That is say this is J cap. Okay, no problem. Why? Because here sin 0, 0. So if I take J cap or K cap here, no problem. Why? Because here sin 0 is there. Sin 0 means 0. So what is the result? 0. So that is 0, 0 bar. Once again see, it is proved that the cross product of any vector with itself is a null vector. Is null vector. Right? So similarly, therefore, I cross I equal to J cross J equal to K cross K equal to 0 bar. Okay. But in case of dot product, I dot I equal to J dot J equal to K dot K equal to 1 in previous result in the dot product or scalar product. But I am writing here, but I dot I equal to J dot J equal to K dot K equal to 1. I dot I, the dot product of any vector with itself is 1. The dot product of any unit vector with itself is 1. Okay, right? That is I dot I equal to J dot J equal to K dot K equal to 1. But here I cross I equal to J cross J equal to K cross K equal to 0 bar. See the variation, right? Okay. Now let us see I cross J. Number 2. I cross J. I am rubbing here. I cross j. I cross j. See, I cap is somewhere here, j cap is somewhere here. Both are perpendicular to each other. Both are perpendicular to each other. See, compare here. One implies I cross j equal to that is a bar cross b bar equal to ab sin theta into c cap. So a bar cross b bar equal to ab. AB means mod I cap mod j cap into sin. See, AB sin theta. A means mod I cap, B means mod j cap into sin theta. What is the angle between I and j? 90 degrees. 90 degrees. 90 degrees. Okay. Into c cap. One unit vector must such that perpendicular to both I, j and plane of I and j. See, this is what plane of I and j. Okay. Here k cap is the unit vector which is perpendicular to both I cap, j cap and plane of I cap and j cap. So it is k cap into k cap. That is I cross j equal to mod I means 1, mod j means 1, sin 91 into k cap. So therefore I cross j equal to k. I cross j equal to k. That is I cap cross j cap equal to k. Similarly, therefore I cross j equal to k, right? I cross j equal to k, j cross k equal to I. Similarly, k cross I equal to j. Okay. Similarly, I cross j equal to k, j cross I means minus k. Why? Because anti-commutative. Cross product not obeying commutative law, but it is anti-commutative. Means I cross j equal to k, j cross I equal to minus k. Similarly, j cross k equal to I, but k cross j equal to minus I. Here k cross I equal to j, but I cross k equal to minus j. Okay. Now this can be realized with one shortcut as shown. Let us see shortcut. What is that shortcut? See, one shortcut. Here one circle. I am taking anti-clockwise sense, that is here I cap, here j cap, here k cap. Okay. Here clockwise sense. Same I cap, here j cap, here k cap. Alright, I j k, here also I j k, but see the sense of rotation, here clockwise, here it is anti-clockwise. Okay, now let us see, this is what I cap, this is what j cap, this is what k cap. Alright, I j k. Now see, cross product of any two orthogonal unit vectors. What are these I cap, j cap, k cap orthogonal unit vectors? Okay. Now I want to get the cross product of any two orthogonal unit vectors in anti-clockwise sense. See, anti-clockwise sense means from I to j, j to k, k to I. clockwise in the sense from J to K, J to I to K, K to J. Okay, right? Now, as far as anti-clockwise is concerned, anti-clockwise, I am going with the anti-clockwise sense initial. Now see, I cross J equal to other unit vector with positive sign. Means I cross J. I cross J means K. I cross J means other unit vector with positive sign. Here positive. So I cross J equal to K plus K plus K. Right? Similarly, J cross K. J cross K means from J to K means once again anti-clockwise sense. J cross K means again other unit vector with positive sign, that is plus sign. Plus I. Okay. Similarly, K cross I. K cross I means from K cap to I cap. Once again anti-clockwise sense. Once again anti-clockwise sense. Okay. K cap I equal to other unit vector with positive sign, that is plus J. Plus J. Okay. Did you accept? Now see. Clockwise sense. Clockwise sense means I am going with clockwise sense this time. That is from J to I means clockwise. From I to K means clockwise. From K to J means clockwise. See? Here I cross JK. J cross I. See the order here. I cap first vector, J cap second vector. Here J cap is first vector, I cap is second vector. J cross I. J cross I means from J to I means clockwise. Okay. As far as clockwise sense is concerned, the cross product of any two orthogonal unit vectors is other unit vector with negative sign. With negative sign means J cross I means minus of K cap. Minus of K cap. Okay. Similarly, I cross K. I cross K means clockwise. Once again, I cross K equal to other unit vector J cap with negative sign. I cross K, okay, right? I cross K equal other unit vector J cap with negative sign minus J. Okay, that is K cross J. K cross J. K cross J means from K cap to J cap. That is once again clockwise sense. Means K cross J equal to other unit vector with negative sign. K cross J equal to minus I. Right? Okay, so this is what a shortcut to get or in assigning cross product of any two orthogonal unit vectors. Okay, one is clockwise sense, another one is anti-clockwise sense. Okay, right? Now, in terms of components, suppose A bar, B bar, so and so. How to get A bar cross B bar? In terms of components. In terms of components. A bar equal to AX into I cap plus AY into J cap plus AZ into K cap. B bar equal to Bx into I cap plus By into J cap plus Bz into K cap. Okay. Simply alphabets. I am not writing any numericals. Simply alphabets. So A bar AXI, AYJ, AZ. B bar BXI, BYJ, BZ. Now how to get A bar cross B bar? How to find A bar cross B bar? A bar cross B bar. How to get A bar cross B bar? Simply determinant. The method of obtaining determinant is nothing but A bar cross B bar. That's all. Determinant. How to get determinant? Say I cap. I am writing I cap, J cap, and K cap. Orthogonal unit vectors I cap, J cap, K cap. Okay. Below I cap, J cap, K cap, I am writing components of first vector A bar. What is the first vector in case of A bar cross B bar? A bar is the first vector, B bar is the second vector. What are the components of A bar? X component X, Y component AY, Z component AZ. So below I cap, I am writing X. Below J cap, I am writing AY. Below k cap I am writing AZ. That's all. Similarly, below AX I am writing PX. Means x component of second vector. Here y component of second vector by. So below AY we have by. Below AZ we have bz. So to get determinant, how to get determinant? So A bar cross B bar is nothing but determinant of I, J, K, AX, AY, AZ, BX, BY, BZ. That's all. Okay. That is A bar cross B bar equal to, what is this? What is the first unit, first orthogonal unit vector here? I cap. So I cap into how to get determinant? See, I am writing first I cap, multiple I cap. Now exclude row and column containing or connecting I cap. See this row and column. Exclude row and column connecting I cap. This is I cap. This is row and column connecting I cap. Now exclude those two, row and column. Now see, we left with AY, AZ, BY, BZ. Okay, I am labeling as A, B, C, D. Okay, A, B, C, D. Now I cap into AD minus BC. AD minus BC, that is AY, BZ. See the order A, B, C, D. So AD minus BC, that's all. AY, BZ minus AZ, BY minus J cap. So I cap into AD minus BC. Similarly, minus J cap into AD minus BC plus plus K cap into AD minus BC. That's minus J cap. Minus J cap means somewhere here. J cap is somewhere here. Now exclude concerned row and column. This is what row and column. Exclude row and column containing or connecting J cap. So this is row and this is column connecting J cap. Now exclude these two, row and columns. We left with AX, AZ, BX, BY. Now label as A, B, C, D. Once again A, B, C, D. Now minus J cap into AD minus BC. That's all. AD minus BC. That is AX, BZ, minus AZ, BX. AZ, BX. Okay. Plus K cap into. Now this time K cap is somewhere here. Again exclude row and column connecting K cap. So see this column and this row. Exclude these two. We left with A, B, C, D. Now AD minus BC. So plus K cap into AD minus BC. So AX, BY, AX, BY minus AY, BX minus AY, BX. That's all. Okay. So this is what cross product of given two vectors. If are given A bar so and so, numericals, B bar so and so. Now say A bar plus B bar equal to, find simply determinant I, J, K below x component, y component, z component of A bar, x component, y component, z component of B bar. Now I cap into AD minus BC minus J cap into AD minus BC plus K cap into AD minus BC. This is what procedure to find cross product of given two vectors. Okay, correct? Suppose these two are parallel to each other or anti-parallel to each other. If given vectors are parallel or anti-parallel to each other, what about cross product of those two vectors? Null vector. Okay, now itself we came across that point. The cross product of collinear vectors always null vector. I am writing somewhere here. If A bar and B bar are collinear means theta 0 or 180. Now A bar cross B bar equal to 0 bar, right? 0 bar in the sense x component 0, y component 0, z component 0. Am I right? That is 0 into I cap, that is I cap into 0 plus j cap into 0 plus k cap into 0. Am I right? Am I right? See, A bar cross B bar of collinear vectors, null vector. That is 0 into I cap plus 0 into j cap plus 0 into k cap. So all the 3 coordinates 0. What are the 3 coordinates here? I into something. This bracket must be 0. Here this bracket must be 0. Here this bracket also must be 0. Am I right? So therefore I am replacing here. See, therefore say this is number 1. This is number 1. 1 implies AY BZ minus AZ BY equal 0. Okay. Similarly, AY BZ equal to AZ BY. That is AY by BY equal to AZ by BZ. Am I right? Am I right? This is what number 1. Number 1. Okay. See, in second quadrant, second multiple, your y coordinate also 0. Therefore, this bracket term also must be 0. So, ax bz minus az bx equal to 0. So, from which ax bz equal to, take this term that side, that is ax bz equal to az bx. Therefore, ax by bx equal to az by bz. Number 2. Right? Now take this term. This term also must be equal to 0 if given two vectors are parallel and anti-parallel to each other. So third component, that is ax by minus ay bx equal to 0. Now from this relation ax by equal to ay bx. Now make it subject ax by bx. Therefore ax by bx equal to ay by dy. So I am clubbing 3. See, ax by bx equal ay by by. Again ay by by equal az by bz. So therefore what is the reference? See once again, ax by bx equal to ay by by, which is equal to ay by by, which is equal to az by bz. So therefore what is the reference? What is the reference? What is the reference? Ax by bx equal to ay by by, which is equal to az by bz, which is constant. See, the ratio of similar components, ax by bx equal to ay by by equal to az by bz, which is constant. All the ratios x by bx, ratio of similar components, x component by x component, y component by y component, z component by z component. All the ratios are same. That is constant. That is positive constant. That is plus k. That is plus k. If theta is 0. If theta is 180, that is anti-parallel vectors. Now this again x by bx equal to ay by by equal to az by bz equal to constant but negative constant, that is minus k this time. So ax by bx equal to ay by by equal to az by bz equal to minus k, provided theta is 180 degrees. Okay. So as far as parallel non-zero vectors are concerned, okay, now the ratio of similar components must be positive constant. As far as anti-parallel non-zero vectors are concerned, the ratio of similar components must be equal to constant but negative constant. Okay. Now coming to examples of cross product. Examples of cross product. Let us see some examples. Examples of cross product. What are the examples? Torque tau bar equal to r bar cross f bar. R bar, moment vector and force vector. Cross product of moment vector and force vector. That is moment of moment is torque. Okay. Number 1. Again number 2. torque tau equal to tau b equal to m bar cross p bar. In case of magnetism, okay, torque acting on magnetic dipole, tau b equal to m bar cross b bar, m bar cross b bar, okay, m bar cross b bar. That is, m is magnetic moment vector, b is magnetic field vector. Related to secondary topics, okay, this is first year topic. Similarly, torque tau e, electric field, torque acting on electric dipole, that is p bar cross e bar, p bar cross e bar. P bar means electric dipole moment, e bar means electric field. So m bar cross b bar is torque acting on magnetic dipole, p bar cross e bar is torque acting on electric dipole, r bar cross f bar is torque acting on device, okay, right? Similarly, number 3, V bar equal to omega bar cross R bar. Number 4, L bar equal to R bar cross P bar. R bar means moment of linear momentum, moment vector, here linear momentum vector. So moment of linear momentum is angular momentum. So cross product of R bar and P bar is L bar, angular momentum vector. Here it is angular velocity vector, here it is radius vector. So cross product of angular velocity and radius vector must be equal to linear velocity vector. Here order is important. You are not supposed to change order of any two vectors in case of cross product. Why? Because cross product does not obey commutative law. A bar cross B bar is not at all equal to B bar cross A bar. We must follow order. Okay. We should not write P bar cross R bar. It is to be written R bar cross P bar, that's all. Here M bar cross B bar, not B bar cross M bar. Here R bar cross F bar, not F bar cross R bar. Okay. These are some examples. Will be known in further chapters. For the time being, accept mathematical expressions, which are examples for cross product or vector product. Okay. Okay, friends. With this signing off, few more points also there in the cross product will be discussed in the next class. Okay, apart from numericals. Okay. So signing off for today. Once again, I am requesting all the audience to please subscribe channel C-Level Physics. Okay. Please share my videos, comment on videos, and like my videos. Okay. Thank you. Signing off.